Okay, cool. Full screen the slides on your computer, it looks pretty small on the screen share. Okay, let me see if I can do this. Can you see it much bigger now? Let me see. Okay. Oh. Oh. Wait, did I show the answer already? Should. Okay. Okay. So sorry. I hope you guys didn't see the answer. Okay, I'm gonna give it like 30 more seconds. All right, I didn't see anyone typing the answer, so does that mean that you guys have not finished? I see someone say A. Sulfur. Very nice. A. Okie dokie. So let's go over. Do you remember to check whether you need to read the paragraph or not? This is the first thing that I wanted to remind you guys, because I remember that when I was going over question with you guys on GenCamp, I mentioned that there are questions, sometimes you may not be able to finish all the questions, but what you can still do is to watch out for questions within the passage that can be stand out as itself, and you can use your own knowledge to answer it. So this is one of the example that I find from AAMC practices. And like oxygen, actually you guys got it all right. So I'm not sure if everyone is getting the right answer or not. But if you are confused, feel free to drop your questions, okay? So like oxygen in the methanogen, which element can act as the electron acceptor? And basically, it's just the thing that I was trying to remind you all about the periodicity on the periodic table. Since oxygen is kind of with sulfur on the same group, so they should be able to like kind of act alike. Whereas if you check out the other ones, helium is obviously noble, hydrogen already paired up, well bond. So iron, transition metal, maybe, maybe not. But then the most likely answer is going to be the element that is on the same group, which is sulfur. And then here's the second question, and I will give you guys again probably 1 or 2 minutes. Okay, 10 more seconds. Yep, I think you guys got it. Hopefully everyone. But you guys, like for one, like first again, this is kind of a standalone discrete questions. Oh, I got a C though. Okay, no problem. So this is kind of like a standalone question. Like even in the passage itself, it doesn't give you. It only gives you the formula of methane, but that is the only thing that you kind of need to kind of think about how the structure is, and then you just compare the structure that you have for the remaining choices that they listed here. So in terms of the option C, actually I thought about that too, because they obviously have four components. For methane is the hydrogen, and for C is the fluorine, and for D is the chlorine. But why would you choose C over D? You're gonna have, you choose D over C, you're gonna have to think about again which group it is exactly, periodic trends. So which group they are in. So silicon is gonna be on group 4, which is the same as carbon. Even if you don't know where xenon is, which is actually, it is a noble gas, I remember, if I remember correctly, you should be able to kind of deduce it by understanding the group, okay? So, all right, so you got it, perfect. We're gonna go to the next one then. Again, we have a lot of questions today. Hang in there. No problem. Let me see if I can work the new structure out. So either if I can do it on my iPad. No. I will draw it out. Don't worry. It's fun. So for this stability question, stability usually involves a couple of things. It can be the strain. It can be like the strain you're gonna go over, ring strain, angle strain, whatsoever strain, a lot of strain. So anything that kind of involve bonding, there's some sort of strain in it. Just think about real human relationship, like because in psychology section they also have this rho string, remember? So all string is kind of like having some kind of bonding that relates to it. And then you're gonna have the induction in terms of having what kind of electron drawing element is around for the induction property. And you're gonna also have the conformation, because even with the same structure, again, this is about geometry for OCHEM, like they can take on different form, and different form has different kind of stability. And then acidity and basicity, which we're gonna go all of them over in forms of questions. So 30 seconds into this question so that we can move on. Let me see. I'm going to try this. Okay, so 30 seconds up, and everyone got B. Just checking in case someone got someone else. Like, you don't have to feel that you have to conform to the group, and in psychology, again, that is like group conform. Some sort of group conformality that you have to remember. I remember. So for B, it says that it is compound 2 because it has the carboxylic group in equatorial position, which this question actually I made it up, but I think you guys all got it. But the additional question is, what kind of strain would be induced by placing a carboxylic group on the axial position? When we talk, yeah, what kind of strain does it induce when you put the carboxylic group on the axial position, so that you kind of know both sides? Why is it put it on the equatorial, and what is the disadvantage on the axial? Yep, steric hindrance. Perfect. Okay, next we're gonna have this question 30 seconds, okay? Okay, I'm gonna give a little bit more time. Remember, you don't have to conform to the majority answer. This is about critical thinking, whether you get to the right answer. So don't be afraid if you didn't get the right answer. It's about learning. Okay, I think I got pretty much everyone. Let's see. Someone say it can't be A because they're both carboxylic group. Okay. Same resonance and same induction. Yeah, right. Very right. Again, the differences is whether it is on equatorial or on the axial, right? Okay, so let's see. And then we have either C or D. Okay. So C is saying it is an inductive effect, and then D says it's the hydrogen bonding between the hydroxyl group and the carboxylic group. So if it is an inductive effect, that is because there's an element that is different, and one of them are more capable. I'm sorry? I'm sorry, what did you just say?
I hear her though. It's that girl, right?
Okay, I'm not sure whose audio is this, but if you can, if you're not having a questions, could you mute yourself? I couldn't quite see who's talking. Let me see. Okay. All right. So if it is an inductive effect, that means that the structure itself, there's an element that is different, and one of them are more capable of drawing electron than the other. For example, fluorine and chlorine, and they may be on the same position, one of them closer, one of them further away. But in this case, they look like they have exactly the same kind of bonding at the same position. It's just that one of them is on the equatorial, one of them is on the axial. So the molecular formula is the same. And really, when you are putting the carboxylic group on the axial, although there may be steric strain, however, those extra electrons can also be held by the extra electron on the hydroxyl group can hold and pull that proton away from the carboxylic group. So leading to that proton being taken off and forming a positive charge on the hydroxyl group. So because the question itself is asking about the acidity rather than stability. So that's why here they would lead to an answer having the compound one a stronger acid. I hope it makes sense given that little disruption. But if we cannot get over this, we'll come back to it later. Okay? So again, remember the stability is also correlating the positively whether you're able to stabilize that anion or cation is correlated to the acidity or basicity, and this is also in the GenChem slides if you want to go over them. And here is the kind of confusing point between stability versus boiling point. And this is kind of introducing questions in terms of what is more soluble in water so that I can bring you guys to understand the differences. So again, I give you guys probably 1 minute. Okay, 1 minute up. I'm just letting some more answer to reply in. Okay, so this question asking which one is more soluble, and one thing that you can be looked for is just recalling yourself that when you're having a lot of methane, like the CH group together, it makes the entire compound not very not very fond about interacting with other electrons outside of their environment. So compound 2, basically, they don't want to hang out with water. They like organic solvent. Again, this is kind of like, remember the IUPAC? Where do they would be soluble? This is one of the example. It will be compound 1, and then we're gonna go over the second question. This is a passage 2 by taking out some of the organic related questions. And I'll give you guys 1 or 2 minutes. Mm. Let me see. No. That's fine. I got it. No problem. Okay, so I'm going to draw this one. Okay, so here, actually, this is one of my favorite um, class when I was in undergrad because I happen to be loving fragrance, and a lot of fragrance has beautiful chemistry structure. And I remember having them on presentation, and I found this one also from AMC talking about this scent that is the caraway seed oil boiled, which one would be likely to be distilled first. Someone is deciding between A or D. So let's break it down. Um, you're basically trying to isolate the two and you wanting to see which one get distilled first. So when it comes to distillation, is the separation between the boiling point. And here I think I didn't do a meticulous job on editing my slides. I already told you guys right here, giving you a huge hint that boiling point is about the intermolecular forces. So the interaction, whether they are able to interact each other, that kind of illustrate the boiling point. So here you can see an extra oxygen that is like sticking right out in the carbon. And if it were being boiled and it is solely just pure either compound, it's likely that that oxygen could be able to interact with something else and, you know, gaining up that being more kind of sticky to each other, more cohesions. Whereas if you look at the other one, it probably because it is like kind of non-polar, so it will lead to less interaction between the molecule. So that intermolecular force would be likely to be lower. So once we settled on which one would having the lower boiling point, then it will be pretty easy to kind of sort out the things because then we just have to find the one that indicate that the lemon is has a lower boiling point. Oh, I you understand that, but it is the kind of oh yeah. So distill when when you say that which one get distilled first, it's usually refer to the one that get evaporate first. That means that they require less energy, less temperature, or less energy or thermal energy that separate, breaking all those intermolecular forces apart and then getting them to evaporate. Very nice. Yeah, I like that you guys are helping each other. Very good. Okay, second question. Go. I'll stop about 90 seconds, okay? Oh, I'm gonna go fast on this one because I don't know if you guys saw that I made a mistake on pressing my enter key. Okay, but we'll go over this really quickly. It differs by an orientation. The plus and the negative sign didn't indicate what configuration it is in, meaning that whether it is R or it is S, it just means that whether it's turning the light to right or left. I remember correctly. Um, so here it asked, and usually if they have a differences in the rotation in light, that means that the stereo center must be different in terms of the configuration. And here it just asked about which one could be possibly different. And if you kind of just remember what makes a stereo center, it makes up four different component that is bonded to a carbon, which happens to be only carbon number 5 here. Carbon number 2 only bond to three things because one is occupied by the pi bond with the double bond, and carbon 7 also have a double bond, so that doesn't work. So the only one is gonna be 5, straightforward. And then here, so this is gonna be the last question before we jump into the passage that I prepared for you guys. So if you do have any question up to this point, drop it now, so I can go over it really quickly before we start that. Um, but if you do not, go ahead and answer the stereoisomer questions. Just wanting to check with everyone that you guys are comfortable of how do you assign R or S for compounds. And let's go. Okay, let me see. So let me see if everyone is. Let me see. This is referring to Alice when configuration. Yes, yes. Configuration is just another word for geometry. I wanted to start it for at 45 the passage before, so that you guys have 10 minutes to work on it. So I'm gonna start going over this question very quickly. So the configuration kind of just means the same thing that I've been talking about. It's just geometry. What do you put in this position? What do you put in that position? And here they are checking if you can read the composition, how they are drawn. So remember that dash is pointing towards the screen, and the cone shape, the solid cone shape, is kind of sticking out of your screen. It's supposed to be. Um, and if you, whenever you assign the priorities of group, I always, I remember that in the textbook, several textbook suggest you to put hydrogen in the back, which here it is sticking right out in the screen. So it doesn't work this case, but I find that you can actually just assign it as is and then refer it. So for example, on the compound A here shown here, because the top one, the one that is pointing to the 12 o'clock, the carbon there is a carboxylic group. It bonds to two different oxygen. It should be assigned with the second priority, because the one down below is an oxygen, which is notably a little bit heavier than the carbon. And then the third one should be the one that is linked to an alcohol group. So going by that order, so you should be having a 6 o'clock, and then going to the 12 o'clock. So that means that is going clockwise. And how I remember is just how do you write the R? So like, you know how R it curves down, like you draw from like a horizontal way and then you curve down. So it also go clockwise. So then I would know that, okay, if I assign this way, it is R, but because the hydrogen is sticking right out and it is supposed to be back. So if I reverse it, it will be S. So I would change R to S because right now it is sticking up. Um, you can also spin it. Yep. Yep. So you just flip it. You assign it as is and you flip it right in the end because you remember very clearly, okay, that the hydrogen, when you assign the group, it needs to be on the back. But if it is sticking out, just reverse it. It works, okay? And if you do everything like one by one, you should get to the D. And here we go. Chemistry passage, and I will give you guys the link. So let me see here. There we go. So I make a separate slides so you guys can look at it on your own, and we will come back because I'm running a little bit late. And from how I like knowing you guys can work through question probably 1 or 2 minutes per question. I know that you guys can handle it probably when we get to like 55. How about? So I will see you guys then. I'm gonna give it probably 30 more seconds just in case you guys want a little bit more time. Okay, I'm gonna start going over this passage. It is pretty short. It just talks about one of the very common reaction that actually happens all the time when we're washing our hands these days, which is just to dissolve that esters that is formed in the triacylglycerol, which I just call it TAG usually. And it say that when it reacts with sodium hydroxide, and then it will produce glycerol and fatty acid salts. And then which happens when you're actually using those soap, and you're gonna have the fatty acid that is soluble. Let me see. Okay, yeah. And then the researcher convert those and analyze those with gas chromatography, which is pretty fun. Okay, and then the first questions asked us that which of the following statement most accurately describes the solubility property of fatty acid salt? Something that we encountered previously about organic structures and related to whether it is soluble in whichever solvent. You can feel free to type in your answer if you want to. If you don't want to, it's fine. Oh, it's fine. Okay, we got pretty much C. And if you just go back to what they talk about, it is a fatty acid salt. And so salt meaning that it can have the charges, which is the sodium in this case, and also the carboxylic group as the anion charges. So that gives them opportunity to be soluble in polar media, because that charges would allow them to interact with some of the hydrogen bonding, possibly if it is water, or the oxygen lone pair in water again, for example. But at the same time, because of the fatty acid, one of the notable features of fatty acid is that very long hydrocarbon tail, and that is pretty nonpolar. So that suggests to you that it should be pretty much dissolved a little bit in nonpolar and polar. But if it is completely dissolved, likely not, because it has the property of the opposite too, which is if you put it in non-polar, it's still charged, but if you put it in polar, it still has that non-polar hydrophobic tail. So the correct answer is C. And the next one, it is about when the glycerol reacts with three different fatty acids, how many stereogenic center? So again, it's stereo center that we're talking about, that the triacylglycerol, the product of triacylglycerol contain. So then we have to go back and look at the triacylglycerol, and we can see that we're looking for, again, something that bond with four different components, a carbon that bond with four different components. And let's see what you guys got. Okay, maybe I should show you guys the options. So that's one. Let me. We have A, D. I thought we were gonna get C too. Then we have everything. Yes, no problem. So remember that stereocenter, stereogenic center, meaning that whether that specific carbon is bond with four different components together, that makes a stereocenter. And that stereocenter then can be assigned either R or S, depending how the configuration is. Again, configuration means how it bonds to different functional group or constituent in the kind of geometric shape that they are in. So if we look at the triacylglycerol, you can see that like they give you R1, R2, and R3, but remember that all those R is just hydrophobic hydrocarbon tail. So that means that they're gonna have a CH3 and then a bunch of CH2 in between, and then once it reaches this carboxylic group, in the end, then you're gonna continue with this free leading carbon that is in the beginning. And if you look at the one that is on the very rightmost column and the very top one, it has two hydrogen. And the bottom one also have two hydrogen. Remember, we're looking for a carbon that bond to four different things. Yeah, what is the answer again? Yeah, we haven't got to that yet, but because the top and the bottom cannot be considered as stereocenter, so only the middle one is bonding to four different things, including that hydrogen, the top carbon, and the bottom carbon, as well as to the oxygen to the left. So the answer would then be B, which is only one. So should we assume that R1 or R and R3 are different? I would consider them different because, let me see. Oh, let me go back. Because it didn't tell you specifically that what are those constituents. It's likely that it is different because usually there are a bunch of different so if you look at the one of the passage right here, actually, the paragraph to say that when it is saponified, the pure triacylglycerol, and then they found that it's four different fatty acid salts were produced instead of three. So the researcher already thinking that these R1, 2, 3 are different, but then they got four. So that should tell you that those chains should be different. I don't think it is an assumption. It's just what the paragraph tells you, that three are expected, but they got four, which comes up with a different question afterwards. So you should consider the R1 and R3 different, and the answer is 1. And then here we have which of the formula represent a general structure of a fatty acid salt produced in reaction 1. And this is literally just asking the fatty acid salt that would look like. Okay, so you're still a little bit confused. If it is different, why not 3? So I am curious that Jolina, how do you get, which 3 carbon did you select? If you can tell me which 3 carbon that you select, I may be able to tell you which one. Why it's not 3, I'm sorry.
Yeah, I think, sorry if I missed your name, Matilde just answered it because I think I didn't
Oh, yeah, yeah, yeah. No problem.
It's just,
No problem.
yeah,
You're good.
yeah, no, it totally makes sense now. Okay.
You're good. No problem. We're here to help each other, okay?
I think I was like looking at the carbon in the center and not the carbons like on the right. And
Uh,
so that's how I got like three
mhm.
um instead. But that makes sense.
Yeah, I'm sure other people might have the same like question as you do too. But it is perfect. We can clarify that then. Okay, we're going back here. So we're running out of time, so we should be speeding. Um, Here asks about the structure, and remember that the end that it is attached to is the carboxylic group right here. So we should see something that is carboxylic along with the sodium as a salt. So let's go. Let's go. Okay, we're here. We're here. Okay. So we can see that for C, no, it's not C, it's this, D. D will have COO and then towards the minus sign perfectly described the carboxylic structure that it should have. And if you kind of a little bit thinking about it, you can imagine a double bonded oxygen that is sticking up and then bonded a single bonded oxygen, and then they are sharing that negative charge. Okay, so the answer is D. Let me check if everyone have any question. Okay, we're good. And then it says this question asks about how much sodium hydroxide needed to completely saponify triacylglycerol. So here it asks about how many equivalent as to one unit of triacylglycerol. And let's see what you guys got. Wait, do you guys already type in already? I think you guys did, huh? D. Yeah. Okay, cool. So yes, it is 3 equivalent because as you can see, if you got this answer right, then you will notice that each triacylglycerol has 3 carboxylic group, and therefore we need 3. Okay, come on. Okay, here we need 3 to completely dissolve all of those fatty acid group together. Okay, this is the last question. Hopefully it is. Which of the following is the most plausible explanation of the fact that the supination of the triacylglyceride in the passage resulted in 4 different fatty acid salts? So, do you guys have answers with that? I think this might be the most difficult one. So I got a lot of D. Okay, no problem. Yeah, so what could be one of the reason is exactly that one of them might be unsaturated, and then that double bond due to unsaturation can be reacted to the hydroxide ion of the base. So that would lead to a hydroxyl group and OH group adding to that double bond, making it to be a single bond, and then you can do it over again to make that double bond in a different position. So then like that isomerization is could be occurred if one of them is unsaturated. And let's see if anyone have any questions. But the answer is D. A small percentage is isomerized. Why not completely isomerized? Because if it is completely gone to another, like that double bond is completely gone to another position, then that means that that isomerization of the original compound would be disappear then they will still get 3 different fatty acid salts instead of 4. So only if a small percentage of it is isomerized, then it allows both species to be exist, and therefore we got 4 different ones. Okay, so I guess are we done? Are we done? I think we're done, right? Okay, I'm sorry to put you guys through so much questions, but like when I was preparing all these slides, I have been thinking that the only way that GenCam can be, no, not GenCam, OCam can be very helpful is only to work through a lot of questions and practice. And I do try to take out the more difficult one to go through with you guys. So tell me how you like the structure of classes next time or this time. And I hope to see you guys all next week. And I guarantee you guys that I try to walk you guys through like GenCam, OCam, but all these things are still applied in BioCam. If ever you guys have any questions, leave questions with on the, I think they have a Slack channel, right? Oh, this is chapter 2, and along with other chapters too. There's more. I think. So I know that biochem is tough, but if you guys ever have any GenChem, GoChem, biochem questions, if you guys are struggling and it is not covered in this lesson, then you guys can drop in that questions on Slack channel. And I hope that if you guys are putting the question, I will be able to see it and answer it accordingly. Let me know, okay? I'm gonna stop the recording because I noticed I haven't. Okay. There we go.